Okay, so we're going to do a series circuit, but we're going to do it in rectangular form versus the polar that we normally do it in. Here we have one resistor, one inductor, and one capacitor. We still have to get X of L and X of C. The voltage here is 20 at an angle of 10. Frequency is 2K hertz. So to get X of L, it's always that same equation, 2 pi FL. We plug it in, 2 times pi times F, which is the frequency, times L, so this is 4 millihenries. And X of L would be 50.27 ohms, and then we add the angle of 90. So we can cross this off, okay, and put 50.27 at an angle of 90. To get X of L, X of C, it's 1 divided by 2 pi FC. So 1 divided by 2 times pi times the frequency times the 1 microfarad is 79.58 ohms, and then we add an angle of negative 90. Cross this off, 79.58, angle negative 90. So our normal calculations, we would just use the angle button in our calculators and everything would be in polar. But to do it in rectangular, okay, to get Z total, we basically have to separate the real part and the imaginary part. The imaginary part would be the capacitors and the inductors. So the first thing we know we have a 200 ohm resistor, so it's 200 plus J0, so there's no capacitor value there. Then for the capacitor, it's 0 minus J, 79.58. For the inductor, it's 0 resistance plus J, 50.27. So now we have a total, the real part and the imaginary part. We have to take the square root, so we take R squared plus J squared. So here we took the square root of 200 plus 2931 squared, and we get a magnitude of 202.14. Okay, but we still have to have the angle. To get the angle for that Z total, we take the arc tangent and we go imaginary divided by the resistor value. So we have the arc tangent negative 29.31 divided by 200. And the reason this is negative 29.31 is because when we take 79.58, a negative, plus this, we actually get a negative 29.31. When we take the arc tangent, then we get the angle. So we put it all together. Our Z total is 202.14 at an angle of negative 8.34. Okay, so to get the current, it's the same equation, E total divided by Z total, but we're not using any angles. So it's 20 volts divided by the magnitude of 202.14 gives us the current of 98.94 milliamps. To get the angle for that current, we're subtracting. We're taking 10 because it was 20 at 10 minus negative 8.34. So we have a total current angle of 18.34. So I total is 98.94 milliamps at an angle of 18.34. When you are getting the I total angles, you subtract the angles, okay? When we get the voltage drops, you're adding the angles, okay? So the first thing we need to do for voltage drops, VR1 is I total times R1. When we take I total, the 98.94 milliamps times 200, we get 19.79 volts. To get the angle for that, we're adding the angles when we're getting the voltage drops. Resistors are always at an angle of 0. Then we have plus 18.34, gives us an angle of 18.34. So VR1 is 19.79 volts at an angle of 18.34. to get VL1, it's I total times X of L1. So it's 98.94 milliamps times 50.27. We get a magnitude voltage of 4.97 volts. To get the angle, remember this had 18.34 plus it was L1, so we had an angle of 90. When we add these two together, we have an angle of 108.34. So VL1 is 4.97 volts at an angle of 108.34. The last, we need to get the voltage for the capacitor. So it's I total times X of C1. It's 98.94 milliamps times 79.58. We get 7.87 volts. To get the angle, again, we're measuring them, so it'd be 18.34 plus a negative 90. We wound up with negative 71.67 for the angle. So VC1 is 7.87 volts at an angle of negative 71.67. When you are getting the angle for the voltage drops, you're adding them. Unlike when you're getting the voltage for when you're getting the current, you're subtracting them. When you're getting the voltage drops, you're adding them. And then we can kind of plot your graph. So this line is the real line. The imaginary line, so the real line is going horizontal. The imaginary line is going vertical. So if we had a Z total of negative, it would be negative 8.34. You would graph it as such. That's for Z total. So anything here and above is going to be a positive angle. Anything below the line is going to be a negative plot for the Z total or voltage angles. Okay, there's more to come.